The 17th century was the era that witnessed the great scientific revolution. During this time, ancient astronomical ideas were based on the thoughts of Greek astronomers such as Aristotle and Ptolemy, who believed that the Earth was the center of the universe. However, at the beginning of this century, scientists like Copernicus, Galileo, and Kepler began to challenge these ideas by developing theories that placed the Sun at the center of the universe, Copernican theory, and improving astronomical instruments for studying the sky, such as the telescope developed by Galileo. Isaac Newton is one of the greatest minds humanity has produced. He is known for being the inventor of many fundamental concepts that shaped the foundation of modern science. He was known not only as a mathematician but also as a physicist, astronomer, and natural philosopher. His most famous achievement is the law of gravity, which changed human understanding of how forces affect objects and laid the foundation for the study of cosmic motions. In addition to the laws of gravity, Newton contributed to the development of calculus, and his work led to significant advancements in astronomy, where his contributions to understanding planetary motion confirmed the validity of Kepler's laws that had been formulated earlier. It can be said that most modern natural sciences are unimaginable without the foundations laid by Isaac Newton. Isaac Newton was born on December 25, 1642, in Woolsthorpe, Lincolnshire, England. His birth occurred at a time when the world was witnessing significant scientific transformations, but his early life was not without difficulties. His father passed away before his birth. Newton grew up under challenging conditions, living with his grandmother after his mother remarried, but he showed a great passion for science from a young age. Unlike other children, he wasn't interested in sports or games but preferred to stay at home reading books. In 1661, Newton enrolled at the University of Cambridge, where he studied mathematics and natural philosophy. He was influenced by many scientists such as Galileo and Kepler. By 1665, a plague epidemic forced universities to close for a long period, prompting Newton to return to his family home in Woolsthorpe. During this period, he began developing many of the ideas that would change the course of science, such as the laws of motion and gravity. Isaac Newton was not just a physicist and astronomer, he was also a brilliant mathematician who made significant contributions to the advancement of mathematics. One of his most important mathematical contributions was the invention of calculus, a branch of mathematics used to study changes and how to calculate them. This discovery was essential for studying motion and natural phenomena that couldn't be understood or calculated accurately before. In 1666, during his period of isolation due to the plague, Newton began working on these mathematical ideas. His main goal was to understand the changes occurring in moving objects. This discovery marked a turning point in mathematical history, as he developed a mathematical method that could calculate infinitesimal changes in quantities such as velocity and acceleration. Additionally, Newton made significant contributions to algebra and other areas of mathematics. Newton and astronomy. Newton's interest in astronomy began through his studies of light and optics. In 1672, he published his famous work Optics, in which he discussed the properties of light and how it affects colors. Through his experiments with prisms, Newton discovered that white light is not a single color, but a mixture of several colors, a discovery that, while not surprising to many scientists of his time, was a turning point in the scientific understanding of light. He also developed the first reflecting telescope, known as the Newtonian telescope, which played a major role in improving the accuracy of astronomical observations. This telescope allowed for clearer observations of the sky by reducing the distortion caused by glass lenses. Celestial motion theory. One of Newton's most important contributions to astronomy was his application of the law of universal gravitation to understand planetary motion. Using the laws of motion he had developed, he was able to explain why planets orbit the Sun and how gravity affects celestial bodies. He believed that all objects in the universe are affected by gravity, regardless of their size or type. This enabled Newton to confirm the validity of Kepler's laws about planetary motion, which stated that planets move in elliptical orbits. Newton and the theory of gravity. The famous apple. There is a famous story that Newton was sitting under an apple tree when an apple fell on his head, prompting him to think about why the apple fell toward the earth instead of flying upward. This moment of reflection led Newton to search for a logical explanation for this phenomenon. He wondered, why do things fall toward the earth, instead of rising or moving in other directions? Newton concluded that there is an invisible force pulling objects toward the center of the earth, which he called gravity. However, Newton went further and explained that this force is not limited to Earth but exists everywhere in the universe. According to his theory, every object in the universe exerts a gravitational force on other objects, and this force decreases with the increasing distance between objects. In 1687, Newton published his most famous work Philosophiae Naturalis Principia Mathematica, in which he laid down the principles of universal gravitation. Newton relied on Kepler's work, using the laws Kepler had formulated regarding planetary motion to develop a mathematical formula for gravity, explaining that the force pulling objects toward the Earth is the same force that governs the motion of planets around the Sun. The laws of gravity. The core idea of Newton's law of universal gravitation is that all objects in the universe attract each other according to the following rule. The gravitational force between two objects is directly proportional to the product of their masses. The gravitational force is inversely proportional to the square of the distance between the centers of the objects. This simple idea was essential in understanding how objects interact, whether on Earth's surface or in the vast expanse of space. Newton was able to prove the validity of the law of gravity through numerous experiments and mathematical calculations. One of the most prominent experiments was his explanation of the Moon's motion around the Earth and the motion of planets in their orbits. Additionally, Newton used his theory of gravity to explain natural phenomena such as tides. Newton's laws of motion. In his work Philosophiae Naturalis Principia Mathematica, Newton did not just formulate the laws of gravity but also presented three fundamental laws of motion that describe how objects interact when influenced by forces. First law, law of inertia. The first law states that an object that is not subjected to any external force will remain at rest or move in a straight line at constant speed. This means that objects tend to remain in their state unless acted upon by a force that changes that state. Second law, the relationship between force, mass, and acceleration. This law states that the acceleration experienced by an object is directly proportional to the force acting upon it and inversely proportional to its mass. Third law, action and reaction. The third law asserts that for every action, there is an equal and opposite reaction. That is, the force that one object exerts on another is met with an equal force in the opposite direction. This law is fundamental to understanding the motion of objects in our world. Isaac Newton's legacy still forms the foundation for many branches of modern science. His understanding of gravity played a significant role in the development of modern astrophysics. His research in mathematics and its relation to gravity was the foundation upon which Einstein built his theory of general relativity. Additionally, his concepts of motion and gravity were crucial in shaping the physical laws that are still taught today in universities. Isaac Newton was one of the greatest minds in human history. Thanks to his scientific excellence, he laid the groundwork for a scientific revolution that changed the way humans think about the world and the universe. His achievements in mathematics, physics, and astronomy continue to influence the scientific world today. The laws of gravity he formulated were the starting point for understanding the universe, and his influence extends across all scientific fields. Newton's scientific legacy will never be forgotten and will continue to serve as the foundation for scientific progress in the future. Don't forget to subscribe to the channel. Thank you for watching. See you in more stories.